Man, I hate calculus. How am I supposed to know the slope of a curve of a given point? Mom! Mom, come here. Mom, I need your help. Mom!
I'm coming, relax.
Okay.
What's wrong, son?
I can't figure out my calculus homework. Can you help me? Please?
Looks...
Come on, Mom.
I'm sorry, but I learned this stuff, like, a long time ago.
Oh, man. Now I'll never pass this class. Is there anything you can do? Is there anyone who can help me with my pre-calculus homework?
Hello, friends. I sense a disturbance in the math world.
Who are you?
Yeah, who are you?
Me? I'm the math wizard. I help concerned students and concerned parents like you learn their math every day.
Well, you see this right here? I don't know how in the world I'm supposed to know how to find the limit of the equation of a line tangent to a curve.
I used to know this stuff in high school, but it's been a while since then.
Have no fear. Math Wizard is here. I'll teach you all you need to know about lines tangent to a curve, why they're important, and how to find their limits and slopes.
Are you sure little Jimmy here has had a hard time grasping some of these concepts this year?
She's right.
Don't worry. I'll turn you both into professionals in only a matter of minutes.
Minutes?
What about this?
Yes, minutes. Follow me! Alright, a lot of times in calculus, you will be asked to find the slope of a line that is tangent to a curve at any given point on the parabola. Before we know how to do it, we must understand why. Can either of you think of any reason why this may be useful?
To calculate the effect of gravity on object being thrown? Possibly.
Huh. What about the curved angle of like an arch or something? Like to measure out the slab of the curve.
Those are both excellent answers. You are correct. Alrighty, I hope that you guys are ready to tackle some serious calculus. Here is the equation for finding the slope of the line that is along the point that is tangent to the parabola. What you're going to do is use f of x plus h, because h shows the change in x, minus f of x, which is the standard equation, all over h. Here, our f of x that we'll be using is negative 3x squared plus 4. And the point along which we'll be drawing our line tangent to the parabola is 4, negative 44. So as you can see, we plugged in the equation of our parabola into the equation that was just given earlier. We have negative 3 times x plus h squared plus 4 minus negative 3x squared plus 4. When you factor all that out together, you end up getting negative 3x squared minus 6xh minus 3h squared plus 4 plus 3x squared minus 4. And as you see, we're going to be able to cancel out here. You see that we can cancel out a 4, a negative 3x squared, and a 3x squared. And that leaves us here with the negative 6xh minus 3h squared. So when you clean all that up, you're left with this equation. And then after a little bit of factoring, you find that you take out the squared here, and you cross out that h, and you cross out that h, and it gets you down here to where you have negative 6x minus 3h, and you want to find the limit of that as h approaches 0. So all you got to do is plug in 0 for h, and this negative 3h falls off, and you're just left with 6x, negative 6x. So, we got rid of that negative 3h, and then all that we're left with is the negative 6x. Now remember, the line that we have touches the parabola at the point 4, negative 44. That's where we get everything from. So, all that's left to do